Welcome to IOQM 2025 solution to the paper. This is for the region 4 and 5 and part 3 of the video. So in this video, I will cover questions 21 to 25. All are 5 marks questions. Okay. So this is the pattern and I'm going to cover 21 to 25 in this video. Yeah, let's check. Yeah, let R be R to R. A function is defined as R to R. Okay, satisfying for f of 3 minus x plus 3 f of x equal to x square for any real x. Find the value of f of 27 minus f of 25 to the nearest integer. So yeah, this problem we know actually. All such problems, what we have to do is either it is 3 minus x or a minus x, a plus x, and a by x. If it is in this format, first thing is make sure that substitute x equal to 3 minus x and get a equation. Then we can solve and find out f of x. Okay, this is a very simple way actually. 4 times f of 3 minus x plus 3 times f of x equal to x square. This is what is given. Now replace x with x minus 3. So this equation will become 4 times f of x plus 3 times f of x minus 3 equal to x minus 3 whole square, which is nothing but x square minus 6x plus 9. Now we have two equations. We can solve them and we can get f of x. Okay, so 3 times e1 minus 4 times e2 will give us minus 7 f of x equal to minus x square plus 24x minus 36, or f of x equal to x square minus 24x plus 36 by 7. Now I just need the values of f of 27 and 25 and subtract them, right? So f of 27 minus f of 25 is equal to 56 by 7, which is 0.8. That's the answer. Okay, so definitely this is a easy problem for 5 marks actually. Okay, I think everybody should be solving this one. Okay, next. Three girls, G1, G2, and G3, each read 4 stories, S1, S2, S3, and S4, and they discuss which one they like. Okay? No story is liked by all three. For each of the three pairs of the girls, at least there is at least one story which is liked by the pair and not liked by the third. Okay, let n be the number of ways in which this is possible. Find the number of squares of the digits of n. Okay, so first thing is we should find out how many ways they read the story, and then we can find that n. Okay, sum of squares of digits. Okay, so what they're trying to tell is there are three groups of girls. Okay, so we know that from three girls we can form three groups: G1, G2, G2, G3, or G1, G3, right, in pairs of two. Right, so this is 3C2 ways. This is clear. Now, what they're trying to tell is look at this function, this one. G1, G2, G1 can like two stories, G2 can like any stories, okay, G3 can also like any stories, okay, but if you look at from the story point of view, S1 is liked by only two people, S2 is liked by only two, S3 is liked by only two, S4 is also liked by only two, okay. One story, one story is not liked by the three girls, okay, only maximum two can like a story, but not three, okay, this is what the question is, okay. And also they mentioned each story of the three each of the three stories, three pairs of the girls, there is at least one story which they liked. Okay, so if you consider this as a group, one group, two groups, and three groups, each group liked at least one story. Okay, and not like and it did not the story is not liked by the other pair. Okay, so pair is also possible. So which means the our fundamental problem is, okay, we need to find out at least three of the books, okay, should be liked by two girls and fourth one by anybody. Okay, right, so you have three groups of girls, each group will like one story, correct, and it cannot be liked by other group, because then it will become all three girls will like the story, right, and all three girls don't like the same story. Okay, maximum is two girls can like a story. So my table is very simple. I need to find out for S1, S2, S3, S4 how many ways it is possible two girls like S1, S2, S3 and nobody likes S4. Then two girls likes S1, S2, S3 and one girl likes S4, and two girls likes S1, S2, S3 and two girls likes S4 also. Okay, this is what my fundamental question. It is a simple permutations and combination problem if you solve from this point. Okay, so first is case 1, 0, 2, 2, 2. So no one book not liked by anybody is 4 ways, right? Because you have to choose which book is not liked by any girl. Okay, so 4 of the books. So one of the books you have to choose in 4 ways, and then 3 books liked by 3 different groups of girls, groups of 2 girls, right? That is 3 factorial ways. You are arranging 3 people in 3 seats, 3 factorial ways, right? So total subtotal is 4 into 3 factorial, which is 24. Okay, now next case. Okay, case 2 is 1, 2, 2, 2. Okay, one story is liked by one girl and other stories are liked by two girls. Okay, so one book liked only by one girl is how many ways? I can choose which story, that is 4 options, into which girl, 3 options, so 4 into 3. Okay, then 3 books, remaining 3 books liked by 3 different groups of girls, two girls basically, that is 3 factorial ways, same way, right, like before. So now that subtotal is 4 into 3 into 3 factorial, which is 72. Okay, case 3, 2 2 2 2, all stories are liked by 2 girls. Okay, now this is simple, 2 books liked by the same group of 2 girls, okay, which is 4C2, because I have to choose which 2 stories and which 2 girls, 3C2, right, 4C2 into 3C2. Then 2 books liked by 2 different group of girls. This is for the remaining 2 books. Okay, remaining 2 books, uh, 2 groups of girls, so 2 factorial ways. Okay, just like 2 people arranging in 2 seats, right? So subtotal here is 4C2 into 3 into 2 factorial, which is 36. Now total of these 3 combinations is nothing but 24 plus 72 plus 36, which is 132. What they asked is squares of digits of n, okay, which is 1 square plus 3 square plus 2 square, which is 14. That is the answer. Okay. So this is definitely a 5 marks question hard. Okay. The first point you need to understand how to what are the combinations possible. That point is the difficult part. Once you decide it is, I mean 2 2 2 and then x, it is very simple. Okay, but definitely it's a hard question. Yeah. Next. Let P be a point in the interior of the triangle ABC, and let AP, BP, CP meet the sides BC, CA, AB in DEF respectively. If BP by PE is 5 by 2, CP by PF is 7 by 3, and AP by PD equal to P by Q, where PQ are natural numbers, and they are in the minimal form, so find the P plus Q. So this is a geometry problem, so important thing is draw the diagram correctly. That is the most important step. So once you draw it, this is my ABC triangle, okay, and P is any point interior, and if you draw a line through P from 3 vertices, okay, they meet at D, E and F, and this is what it is. So let's assume these sides are M is to 1 ratio, N is to 1 ratio, and L is to 1 ratio. Okay, so 2 ratios he has given, which is BP by PE he gave. This is M is 5 by 2, and L is CP by L is 7 by 3. These two he has given. We need to find the basically the third ratio, that is NP by Q, right? That's it. Okay. So yeah, this problem is actually easy for at least I would say class 9th onwards. Class 9th to class 12th, it should be easy because they know there is a formula for this ratio actually. Okay. And once you know that this is actually a easy problem in for a 5 marks question. Okay. So for 8th class kids, I don't think they will know, but if they know, this is very easy actually. Okay. So 1 by 1 plus m, okay, plus 1 by 1 plus n plus 1 by 1 plus l equal to 1, or in other way, okay, AP, this part, by AD, complete line, plus BP by BE plus CP by CF equal to 1. Okay, this is what is the important formula which I am talking about. Once you know this, you just substitute. You know already m and n values, correct? M is 5 by 2, n is 7 by 3, L is P by Q. You substitute it. You will get the value for L. Okay, you simplify because there is only one variable and one V equation, right? You will get the value of L. L is nothing but P by Q, right? L equal to 41 by 29 in the minimal form, which is P by Q. So P plus Q is 70. That's the answer. I'm sure this is actually looks very, very easy problem, but just to consider 8th class students, I would say this is moderate. Otherwise, it's actually easy problem and easy for a 5 marks actually. Okay. So next, if A and B are positive integers satisfying 4A plus 4A square plus 4 equal to B square, what is the maximum possible values of A plus B? Okay, yeah, this is a simple number theory problem. Okay, but yeah, you should know a few things. What is the condition you have to take is very, very important from this given equation. Okay, so that is where all the trick lies in. Okay, so I would say that 4a I can write it as 2 to the power of a whole to the power of 2. Okay, so in that case, b square is between 2a 2 to the power of a square and 2 to the power of a plus 1 whole square. Correct. So this is the important step which I am talking about. Okay, b square is between these two. Okay, okay, in normal sense actually you don't get a square between two consecutive squares, correct? So we will only get the upper bound of this b value. Okay, I mean upper bound condition we get, from there we can derive it. Okay, this is only to get the condition. This is the most important step which I am talking about. Okay, most of you would not be thinking this is a condition actually, right? Because you have 2 to the power of a, 2 to the power of a plus 1. This is consecutive integers. Between squares of two consecutive integers, you will not find other square, correct? So let's see. So I'll take one of the conditions, okay, to find the upper bound. So b square is less than 2 to the power of a plus 1 whole square, which is nothing but if I expand, what I will get is b square is this value, okay, 4 to the power of a plus 4a square plus 4, and less than 4 to the power of a plus 2 to the power of a plus 1 plus 1. So if I minimize, this is my final equation. 4a square plus 3 less than 2 or 2 to the power of a plus 1. Okay. So I can actually take few numbers and try it here. That is the very easy way to find the upper bound. Until what point this equation is satisfied. Okay. So if I see actually at a equal to 7, which is not too big. Okay. You are just trying 7, right? So you can start with the 10. You will go wrong. Okay. Then you come down. You will know at 7 it is satisfied. This is the maximum value. Okay. So 4 into 7 square plus 3 equal to 199, which is less than 2 to the power of 8, that is 256. Okay. So hence a greater than 7, there cannot be any solution possible. So maximum bound is a equal to 7. Now you check all 6 values. 1, 2, 3, 4, 5, 6 you have, because you have to take only positive integers, correct? So out of this you will get a solution for a equal to 2. Okay. At a equal to 2, you get the this equation, the given equation 4 to the power of a plus 4a square plus 4 equal to 36 will be satisfied actually. Okay, which is 6, I mean b square means you will get 6 square actually as the answer. So a comma b is 2 comma 6, which means and you also get actually a equal to 4 also. Okay, another number where it is satisfied, a comma b equal to 4 comma 18. Okay, so okay, the question is maximum not minimum. So maximum is a plus b, which is equal to 4 plus 18, which is 22. That's the answer. Okay, so I would consider definitely a hard for considering the condition actually for any class actually this is a very hard problem. Yeah. Next, how many natural numbers n less than 105 are there such that 7 divides 2 to the power of n minus n square? Okay, so this is a definitely a easy problem for a 5 marks question. Okay, it's a remainder theory problem. Very simple. You can split it into 2 to the power of n divided by 7 and n square divided by 7 and solve it very easily. Okay, so the given problem is nothing but 2 to the power of n minus n square congruent to 0 mod 7. This is what you need to find, and n condition is n is less than or equal to 105. Okay, you may get two big number 105. You have to keep on trying for 105. Do you require that? That is where you need to decide. Okay, so that is very simple. You find the periodicity of the 2 to the power of n and n square when it divided by 7. Then that's all you need actually. Okay, you can just find up to that point. Okay, so if you find 2 to the power of n congruent to x mod 7 and n square congruent to y mod 7, and if x is equal to n, which means when I subtract these two, I get a remainder of 0. Correct? That means 7 divides the difference of 2 to the power of n and n square. Right? So I should find a x equal to y, and I should just make a table. Okay, and only thing is check the periodicity of the both. That's it. So I take n 2 to the power of n mod 7, n square mod 7. Okay, for n equal to 1, I get both different actually. Remainders 2 and 1. For n equal to 2, I get both same. For n equal to 3, different. Okay, and n equal to 4, 5, 6. This is how I write, and I see, observe it. For 2 to the power of n mod 7, 2, 4, 1 is the periodicity. Periodicity is only 3. Every 3 it repeats. Okay, and for n square mod 7, 1, 4, 2, 2, 4, 1. Okay, and then 0. As of now, it has not repeated. Let's see. Okay, so next if you take it again repeats. Okay, for n square also. So n square mod 7 periodicity is 7. 7 and 3. So it is good to check up to 3 into 7, that is 21. Okay, and then decide for the rest of the 105. Okay, so up to 21 if I count, I get around 6 which are matching remainders. That is where 2 to the power of n minus n square will be divisible by 7. Correct? So 6 in 21. So how many in 105? That's all we need to, right? So that is nothing but 6 into 105 by 21, which is 6 into 5. That is 30 numbers satisfy this above condition. Okay. Yeah, definitely this is a moderate question for a 5 marks actually. And given in this paper, actually questions are tough. This is definitely easy. I think everybody should score this 5 marks. This is, I think, starting from 8th class to 12th, everybody should know remainder theory. Without that, entering into Olympiad is of waste. Okay. So that's it. These are the 5 questions which I want to talk in this video. Okay, and I will come up with the next 5 questions for the region 4 and 5, IOQM 25. Till then, keep doing maths. Thank you.